my dad had a big long pole. This only worked at home because he didn't carry this pole around with him. A big pole about 20 feet long, made out of a little fir tree. Okay, then he had a block of wood that he would put under it, and he had a lever with a fulcrum. Okay, he would pull down on this end, and this end would go up. Well, let's say the front end of the car weighed 1,000 pounds. All right, and my dad weighed 200 pounds. All right, what mechanical advantage, what's the least mechanical advantage that my dad needed in order to raise the car with his 200 pounds of weight? Can anybody figure that out? Somebody ought to be able to figure that out. What do you think, Tanner?
800 pounds?
Huh? No. Mechanical advantage now. It's going to be a relatively small number. What's the mechanical advantage he needed, Harley?
200 pounds?
No. Mechanical advantage, Jeremy?
100 pounds?
No, the mechanical advantage he needed was 5. Why? How did I get the number 5, Emily?
Because if you took because let's say that, okay, the 200 was 2, and the 1,000 was 10. 10 divided by 2 would equal 5.
Well, 1,000 divided by 200 is also 5, all right? Okay. Well, so he needed a mechanical advantage of at least 5, so he made sure the fulcrum had a mechanical advantage of at least 5. Then he could push down here with his 200 pounds and lift the car off. But there was a problem. Does anybody see the problem that my dad faced next? What is the problem he faced next, Wyatt?
Well, if he was pulling it down, he's gonna get under it.
If he was pulling it down, he couldn't change the tire. So he had to have somebody else sit on this once he pulled this down. Guess who that was?
You.
That was
Me.
That was me.
Oh
Okay.
gosh.
Now, but my weight was only 100. Now my dad pulled down on the pole, and then he had me sit on it. He pulled down with his 200 pounds. He had me sit on it, and then he let go to change the tire. Who wants to describe what happened next? What happened next, Kendall?
He flew off the thing.
I got launched.
Oh my gosh.
All right. Now, how many times do you think I let that happen?
All the time.
How many times do you think I let that happen, Harley? Once. Thank you, Harley, for having faith in my intelligence. I wasn't dumb. I only let it happen once. Okay? What did I do to be sure that didn't happen the next time my dad asked me to sit on the pole? What did I do, Janelle?
You held on.
Well, that could have been what I did, but that's not what I did. What did I do next, Tia?
You said no thank you?
No, I couldn't say no to my dad. My dad was from the old school. His kids didn't say no to him. Okay, Chase, what did I do?
You ate more?
Well, that's a pretty good solution. Right now, I could hold it down. Okay, Jake?
You move the block of wood?
I moved the fulcrum so that the mechanical advantage was at least 10. Why did I want a mechanical advantage of at least 10, Jeremy?
Because 1,000 divided by 100 is 10.
Right. So if I had a mechanical advantage of 10, then I could have, but I wanted to be really sure, so I made sure that the mechanical advantage was at least 11. Because I didn't want to take any risk of getting launched again. Okay, well that's a practical application of lever. Janelle?
When you got launched,
What?
when you got launched, what happened?
Well, I'll tell you, I suffered a concussion and I don't remember. Okay, that's the end of this. The focus today is called the pale leaf, P-A-L-E. And the problem is, why is leaf be pale? And we're going to try to gather enough data to form a conclusion and answer to that question. The focus is comprised of 2 jars. Each of these jars has a liquid, and each one has a leaf in it. Now, you should be able to see that this leaf is bright green in this jar. Raise your hand if you can see that that's bright green. Okay. Now, you'll notice that this leaf is not bright green. It looks a little bit brown, or what I call pale. Okay, so there's a reason for this one being pale, and that's the manipulated variable that we're going to try to identify. Okay, so you may ask me questions about the jars, the liquids, or the leaves. Anything that you think might help to develop a conclusion. What would you like to know, Emily?
Are the leaves the same?
Okay. I'm gonna put it a little bit differently than what you said. Are the leaves from the same plant? That's a little bit different than what she said, but this covers more. Yes, those 2 leaves are from the same plant. All right. Are the leaves a manipulated variable?
No.
Who can tell the class why you know that the leaves aren't the manipulated variable? Why do you know that, Jake?
Because they're the same.
Okay, anything that's the same is what kind of variable? What's the other kind of variable besides the manipulated variable? What? Controlled variable. So the leaves are a controlled variable. All right. So the leaves are from the same plant. Good. That's good to get that out of the way. All right, Tanner.
Are the liquids the same?
Are liquids A and B the same? Well, if they're different in even one way, then I'd have to say no, right? So I have to say no, they're not the same. All right. Who can tell me in one word what the manipulated variable is, as you know it so far? One word, Jackie.
The liquid.
Liquid. Right. The liquid is the manipulated variable, but that doesn't tell you an awful lot. Are the jars a manipulated variable? How do you know the jars aren't a manipulated variable? How do you know that, Mason?
Because you know that it's the liquids.
You know it's the liquids. How many manipulated variables do you want in any properly designed scientific experiment, Darby?
1.
Who can tell me why you only want one manipulated variable in any experiment? Why, Emily H?
Because it would be too hard and confusing.
Well, right, but there's another, who can put it another way, Jeremy?
You can't figure out which one's causing it.
You don't know which one's causing the result. The result here is that this leaf is pale, and that's caused by a manipulated variable. If the leaves were different and the liquids were different, what would be wrong with that experiment? What would be wrong with it, Harley?
You wouldn't have the same materials. Well, you would have. You're supposed to use the same materials in the first grade.
Okay, who can put it a different way from what Harley said, Emily?
You wouldn't know if it was the liquid that was causing it to do that or the leaves.
Right. You'd have 2 manipulated variables. Okay, well, what should we find out next? Who wants to ask me a question now? Janelle?
Did you put them at the same time?
Oh. Well, I'm gonna write that down. Did you put the leaves in the jars at the same time? Here's a chance to vote. You're gonna vote on whether I put the leaves in the jars at the same time. How many say yes, I did? How many say no? who can tell Janelle, well, in fact, Janelle's got her hand up. Why should you have known that I put them in at the same time, Janelle?
Because it's the liquid that's different.
Okay, who can put it a different way? Garby.
The liquid is a manipulated variable.
So they had to be put in at the same time, otherwise you'd have two what? Manipulated variables. Okay, good. Yes, I put them in at the same time, okay. But that was a possibility. All right, who's got another question? Kendall?
Is it pickle juice in B?
I get that question a lot. Does B contain pickle juice?
It does look like pickle juice.
Does B contain pickle juice? No. Does it look like pickle juice? Yes, and these are pickle jars. Did anybody notice that? Farman's pickle jars.
I thought it looked like a pickle
All right,
jar.
who can give me the name of a color that describes the color? What color is that? What color is that, Chase?
Olive green.
Okay, well, let's just say green, light green. Okay, it almost looks yellow, but it's more greenish. All right, so liquid B is green. Well, let's pursue liquid B. Well, we have to pursue liquid A and B both because we don't, all we know is that B is not pickle juice, right? Okay, well, I haven't written the answer yet. No, it's not pickle juice. Okay. But I frequently get that question about B. Okay, who would like to know something else about the liquids? Wyatt?
Does A contain any water?
Okay, good simple way to start. Does A contain any water? Yes. All right. Who knows the control question for 5? Jackie?
Does B contain any water? Any water?
Any water. Oh, I wrote the wrong answer. I almost gave you the wrong data. Does B contain any water? No. All right. Now we can write a tentative conclusion. Well, actually, we could have written a tentative conclusion on the basis of number 2. On the basis of number 2, what would the tentative conclusion have said? Can anybody tell me what it would have said? What would it have said, Emily? Because, right. I forgot to write it down. Okay. Now what can we say on the basis of 5 and 6? What can we say as a tentative conclusion? Harley?
The liquids are different?
Well, that's what Emily said. We can say more than that now. What can we say now, Allie?
That it contains water and stuff.
Okay, good. That's tentative. Who remembers what the word tentative means? What's a synonym for tentative? What?
Well, there's like, it's just like temporary. I don't know if it's temporary. Yeah, that word.
Temporary, right. All right. Because A contains water, but B doesn't. All right, now that's based on the data we have. That can be called valid and reliable. I've used those words with a lot of the conclusions that we've had, the tentative conclusions we've had. There are 2 conditions that determine whether a conclusion is valid and reliable. Who knows one of them? What has to be true for a conclusion to be valid? What? What's one? One
None
condition.
of the data refuses it.
None of the data refute it. I find that a lot of my students have a hard time remembering that word. Who you tell the class what refute means?
Proves false.
Prove false, right. Okay, none of the data refute it, but the data do what? The data do what? Okay,
Pretty much encourage it
what's another synonym for encourage that I use? Support it. The data support that? and none of them refute it, so it's valid and reliable. But why isn't it good? Why isn't it a good conclusion yet? Why, Mason?
Because
It doesn't tell you how to set it up. Good. Okay, now, I'm gonna go back up to the top so you can see it easier and I can write easier. Well, who can figure out what we should find out next? We know that A is water. We know that B isn't water. What did we find out next, Jonathan?
does A contain any sugar? B.
Does B contain any sugar? Well, in other words, we want to find out what B contains, right, Jonathan? Does B contain any sugar? No. Well, now that we've decided we have to find out what's in B, I'm going to give you some clues. Does B contain blank? Yes. All right. Now, here's some clues about liquid B. At the start, it wasn't green. It was colorless. A clear, colorless liquid found in my bathroom medicine cabinet. What could it be? What could it be, Chase? Tell him what he's trying to say, Justin. Jake,
Mineral oil?
not mineral oil. Megan,
Peroxide.
you got, oh, well, it could be peroxide, right, but it's not peroxide. What's another one that's found in the medicine cabinet, Megan? But it's not. Okay, Jessica. Rubbing alcohol. Rubbing alcohol. Okay. Rubbing alcohol. Okay, so now I can check the conclusion because we have some new data. Because A contains water, but B contains rubbing alcohol. Rubbing alcohol. Okay, now it's better. In fact, I think you could probably know how to set it up now, so we might be able to call that good. But there's something we have to add eventually. Raise your hand if you have an idea where that green color of liquid B came from. Where do you think it came from, Megan?
Came from the leaf.
9. Did the green color of B come from the leaf? I'm going to have you vote. Here's a question you're going to vote yes or no on. Did the green color of B come from the leaf? Raise your hand if you think the green color of B came from the leaf. Raise your hand if you think it didn't come from the leaf. How do you know it came from the leaf? There are 2 ways you can tell that it came from the leaf. Name one of them, Jonathan.
Because the leaf is that color.
Okay, well, you actually covered both of them because the leaf was green and it's not green. The liquid was colorless and now it's green. Okay, so the color came from the leaf. Now, how did the color get into the liquid B? How did the color get from the leaf into liquid B? What do you think, Jeremy?
I think it's like, since it was inside the rubbing alcohol, it did something to it to make it for, it dyed with it, the colors and.
Okay, well, Jeremy likes to give complicated answers, right? Okay, I'm gonna boil it down to the essentials, Jeremy. And I'm gonna give you first chance to fill in the blank.
Okay.
Did the alcohol that's a verb, the